Hello everyone, my name is Wenyu Shen and I'm working for NTT Communications. It is really my honor to give this presentation in this great Layer 123 event. Today, I will present our latest activities in developing a cloud-native edge computing platform. By utilizing this platform, we are planning many new promising services, including local 5G, IoT, and AI. Before we go further, please let me give you some background and motivations of this activity. As shown in the left picture, single data center and single WAN once was the standard topology of the enterprise ICT system. While with the rapid evaluation of the cloud and WAN technologies, we have seen an obvious paradigm shift towards hybrid ICT, in which hybrid cloud, hybrid WAN have been penetrating into the enterprise ICT system. In many efforts striving for realizing the hybrid ICT, I would like to mention the initiatives inside ONOG, a well-known North American user group. At that time, ONOG proposed the SD-WAN concept as an implementation of hybrid WAN, which has brought a huge impact on the industry. Recently, adding new components such as hybrid cloud, the group has set a new goal to realize hybrid ICT. Now, detailed requirements for realizing the hybrid ICT are being defined in parallel in multiple working groups in the community. As an operator, by taking advantage of our unique strengths, we have been offering such a platform to realize this hybrid ICT. First of all, we launched a new service called Flexible Interconnect FIC last year in order to offer advanced cloud connectivity. By utilizing FIC, easy and on-demand connection between branches and public cloud services such as AWS, Azure, GCP, and data centers become possible. What's more, we have started to provide an IaaS infrastructure called VXF platform in order to offer value-added function for the FIC service. It is an open platform in which a customer can bring his own functions, and the bringing functions can be further added into a running service chain. This picture shows a typical deployment model for realizing hybrid ICT based on the platform discussed in the previous slide. First of all, we can deploy an SD-WAN gateway on the VXF platform. This SD-WAN gateway can terminate the regional traffic and help the connection to multiple clouds such as AWS, Azure via our FIC service. At the same time, we can also deploy other VNFs such as proxies or UTMs on the same platform easily in order to quickly construct platform, a regional internet gateway, or terminate remote access, or even offer WAN optimization. Furthermore, we provide a backbone network for inter-regional communication. In such case, people don't have to worry about the communication quality between the branches, which are even scattered globally. However, we have seen some new changes in customer needs when they move towards digital transformation. So far, infrastructure-related functions such as SD-WAN, firewall are mainly required. But now, users are asking for more and more upper-layer functions such as self-driving, remote control, IoT, and so on. With this thread, container-based cloud-native functions have become dominated rather than traditional VNFs. Moreover, in order to pursue low latency, reduce cost, and guarantee privacy, there is an increase in the need to migrate the system in the cloud, to the edge, and even on-premise. The new edge computing platform is our answer to the customer requirements. It is a three-stage platform across clouds, network edge, and custom edges. Regarding the network edge, it supports not only existing VNFs, but also new cloud-native functions CNFs, such as AIoT and 5G. The platform directly connects to our flexible interconnect fake service, which means that on-demand connection to public clouds and SaaS can be achieved in few clicks. We also support lightweight edges, which can be deployed on customer premises. In addition to the new AIoT and 5G applications, SD-WAN VCP can be loaded so that the custom edge is capable of terminating the existing VPN services as well. Last but not least, we provide a single pane of glass for managing distributed clouds, network edges, and customer edges. As a result, an end user can select the most optimal location for running the applications. Let me share with you some design details behind. To begin with, this slide shows the design around networking, which specifically aims at improving throughput. Here, DPDK and SRIOV technologies are adopted in the very beginning. In the DPDK context, in order to achieve high throughput, we make the vSwitch run in the user space instead of the kernel space and associate the data processing thread with the designated CPU cores. For some specific use cases, which request even better throughput, we utilize SRIOV to connect a VM or container directly to a physical NIC. As demonstrated in the right chart, while rate is expected to be achieved by introducing SRIOV. We have studied the investigation with great expectation on the FPGA offload for vSwitch, which is regarded as another approach to achieve high throughput, taking a good balance among performance, cost, and flexibility. In this new approach, the data forwarding pipeline in vSwitch, which is used to be processed in CPUs, will be further offloaded and processed into a FPGA chip, known as a programmable hardware. As a result, the saved CPU cores can be applied to more VNFs and CNFs without performance degradation. Let us change the view a little bit to the design effort that we have made in order to improve the performance of computing processing, such as AI inference. We provide compute nodes with FPGA and GPU chips onboarded, so that the upper layer application is able to utilize these hardware resources via dedicated device drivers. As shown in the right picture, an application will be automatically scheduled to the optimal node and applied to the optimal hardware resources, CPU or GPU or FPGA, by defining the hardware requirements in a very simple manifest file before deployment. This is a video showing the effect of using FPGA, in which we utilized an image analysis application developed by Fujitsu. As shown in the video, nearly real-time image processing can be achieved by offloading the processing on FPGA, while we see huge latency in the case of CPU utilization. At the same time, we are also taking several approaches to facilitate the constructions and operations. Zero-touch provisioning for a custom edge is regarded to be a very useful function when we set up a platform in an office building, convenience store, hospital, and so on. With zero-touch, a branch can be provided in a very rapid way by simply connecting a white box server to the WAN without much on-site work. Moreover, after the setup, the required functions can be deployed on demand from a service catalog. We adopt inexpensive general-purpose white box for the custom edge, but we also support BYOD, which means that a customer can even bring in his own device. Centralized management is another feature of our edge computing platform. Based on the idea of running edge computing everywhere, the edge platforms can be set up very easily everywhere, from cloud, network edges, to even custom edges by utilizing a centralized edge controller. We can also use this edge controller to distribute applications remotely to a specific edge as necessary. Please also note that the edge platform can be deployed on not only facilities that are provided by our own company, but also even the public clouds that are provided by our partners. This feature is super important, especially in a global deployment scenario. I would like to share with you two potential use cases based on our edge computing platform. The first use case is local 5G. By utilizing the edge computing platform, distributed replacement of a 5G system according to the characteristics of individual components becomes possible. For example, we can deploy VRAM on a custom edge, UPF on a network edge, and the rest of the 5G core functions on a public cloud. In this case, by deploying the UPLAN processing unit at the edge close to the end user and chaining to the make functions locally makes extremely low latency services not a dream anymore. Also, multiple WAN slices can be created for individual applications by utilizing SD-WAN segmentation capability. Another use case is the AIoT edge, which is also a hot topic these days. New business opportunities are expected by deploying machine learning functions locally. In addition to the traditional network functions such as SD-WAN, advanced processing functions such as data shaping, local inference, automatic control can be executed locally very close to the end user by deploying functions such as AWS Greengrass, Azure IoT Edge on the custom edge. The custom edge is also expected to facilitate and accelerate the deployment of our own IoT and AI solutions, such as Takumi Eyes, Deep Detector, and Things Cloud. This slide briefly explains a product inspection example, but it is also possible to apply the technology to other use cases. In this demo, I will show you how we can easily set up an on-premise custom edge and run an AWS Lambda function locally. Also, I will show how we can switch an application to another one on the same customer edge. First, we need to create a template in advance. Here, we can choose a white box type that best fits the use case and send it to the destination location. In the marketplace, there are multiple options in different categories such as AIoT, VPN, security, and mobile. Let us select AWS Greengrass this time. That is all what we need to do in advance. When the box is received on site, just provide the power and connect it to the internet, and then the magic will happen. Let us go to the AWS console. Now we can check the Lambda function, which is now running on the branch office locally. It is just a simple Hello World example. And now we can confirm that the messages have been sent from the branch office to the AWS console. In the next scenario, I will deploy a Kubernetes cluster on the same custom edge to replace AWS Greengrass. Just like this, all the modifications can be achieved in a very easy way. After the Kubernetes cluster has been successfully deployed, I will show you how we can deploy an OpenVINO-based container image on the cluster. This demo shows a very simple example to identify the characters inside the picture locally on the custom edge. As shown here, the container will be downloaded to and executed on the custom edge, after which the result will be sent back to the cloud. Thank you for your listening. In this presentation, I presented how our platform offering can respond to the paradigm shift towards hybrid ICT. Please remember the key enabler, our flexible interconnect, and the VXF platform. Moreover, we have started our new edge journey together with our customers, focusing on the use cases including local 5G and AIoT. We believe that the new three-stage cloud-native edge computing platform that I demonstrated today will greatly accelerate the progress of digital transformation for our enterprise customers. Hope I can share with you more successful story about our edge journey next year. Have a great time in the event. Bye-bye. Hello everyone. My name is Wenyu Shen and I'm working for NTT Communications. It is really my